Hello class, this is Mr. Lehman. I want to continue with our discussion on lesson 16, get into STP and Avogadro's Law, and how this applies to gases, how the mole applies to gases. Alright, so STP, what does that mean? STP, standard temperature and pressure. So scientists all over the world want to be talking about gases, and when they talk about it, they need a set of standard conditions, so that way they can, talk back and forth and be talking about the gas and figure out the number of molecules and things like that. And so they need to make sure they're talking about the gas at the same temperature and same pressure. And so scientists have elected standard temperature to be 273 degrees Kelvin, which is equal to 0 degrees Celsius, which is equal to 32 Fahrenheit. Why I picked this is because it's a freezing point, melting point of water. It's a pretty big event as far as nature goes. No matter where you're at in the world, water freezes and melts at 32 degrees Fahrenheit. So that's why that was selected. Pressure, standard pressure is 1 atmosphere. This is standard pressure on average if you're at sea level. Alright, so these are the standard conditions at which gases are compared from all over the world. Alright, so if you have 1 mole of a gas sample, it's going to occupy 22.4 liters of space. So 1 mole of a gas occupies 22.4 liters of space. And so Avogadro's law, what he said is it doesn't matter what identity the gas is that's filling up the container. You could have oxygen gas, carbon dioxide gas, nitrogen gas. No matter what gas it is, at STP, if you have 1 mole of that gas, it's going to occupy 22.4 liters of space, regardless of the identity. 1 mole of gas, 6.02 times 10 to the 23rd molecules of gas, or atoms of gas, are going to occupy this much space. And so with that being said, if we had 2 balloons, our balloons are both at STP, standard temperature and pressure, 273 Kelvin, freezing point, melting point of water, and 1 atmosphere of pressure at sea level, then which balloon contains more molecules? 10 liters of helium or a 20-liter CO2 balloon? Hopefully you said the bigger balloon. This balloon contains more molecules because it's taking up twice as much space. And so if it's taking up twice as much space, there are 2 times as many molecules inside this balloon versus this one. In order for a gas sample to be twice as large, it would have to contain twice as many atoms. Moving around inside, colliding with the balloon, pushing the balloon outwards. Alright, so that was what lesson 16 was all about. Supplying the moles to gases. Hope this helped.